Hello and welcome to your first of what is hopefully not too many online maths lessons. Hopefully we'll get IST back up and running before too long, but for now we're going to try and do some stuff online. Okay, so you're going to need a few things today. You're going to need something to write with, pen or pencil, something to write on. Hopefully you can find some paper, preferably squared, although I'm sure that's difficult to come by. Hopefully a ruler and a calculator today. We're going to look at something called Pythagoras' theorem. I'm just showing you this nice little optical illusion here of what I'm doing is I'm filming the computer showing me the recording. But we're going to do most of the work just on pen and paper here. Okay, so what I've got here for you is a title, Pythagoras' theorem, and a little starter for you to do, because answering questions of Pythagoras' theorem involves a lot of squaring and square rooting. So a quick reminder of what that means. So we had something like 3 squared. What I'm doing there, it is not 3 times 2. If I wanted to do 3 times 2, I would tell you to do 3 times 2. It is 3 squared. What you can do is imagine a little square there, which is 3 by 3. And what you're doing is working out the area, or counting how many squares in the middle, 9. In other words, you're doing 3 times 3. Okay, 3 squared just means times by itself, 3 times 3. For the latter ones, the square roots, if I said, for example, the square root of 16, what I'm asking you there is, what square would have an area of 16? Or in other words, what number, when you times it by itself, makes 16? And there's not really a method for this, other than if you want to try drawing squares. It's more just have a little think about it, maybe have a little guess. If you guess, say, 5, well, what does 5 times 5 make? That makes 25, so that's too big. So we try something lower than 5, maybe guess 4. What's 4 times 4? Oh, it's 16. So the square root of 16 is 4. Okay. But just if you have a quick pause of the video, make sure you got some paper handy, write your title, and just have a go at those few questions. And then when you're in pause, I'll be ready to just quickly give you the answers. Although I'm scared that I've actually just given you the answer to the first one if you look at my example of square root. Right, so answers. 4 squared, that makes 4 times 4, which is 16. 8 squared, 8 eighths are 64. 11 squared, that's one people find difficult. People don't know the 11 times table when it gets over 11 times 9. That is 121. 9 squared is 81. Then a few squared roots. Square root of 9 is 3. Square root of 25 is 5. Square root of 144 is 12. Now you could argue that answers to E, F and G would also be -3, -5 and -12. So if you've put both, well done, but I'm only really interested in the positive square root today. And technically this symbol does refer to just the positive square root, not the negative as well. But -3 times -3 would also equal 9. So you could say that -3 is the square root of 9. Anyway, moving on to Pythagoras' theorem. What I would like you to do, hopefully you've got a ruler, and what we're going to do is I'm going to draw a triangle. Okay, so Pythagoras' theorem is all to do with right-angled triangles, and he was an ancient Greek bloke, so he lived a couple of thousand years ago, and he discovered something about triangles. Okay, we'll start by drawing a triangle. I've got a little ruler on the inside here, so I'm going to make one of my sides be 3 centimeters long. Try and make it nice and straight. So you can see my squares aren't exactly the right size for this. But one side 3 centimeters long, and the other side of the bottom here is going to be 4 centimeters long. And then I'll be able to draw in a line here to finish off the triangle. Okay, and what Pythagoras' theorem is going to be able to do is to be able to tell us the length of that line without us even measuring it. Okay, so I'm going to tell you now that the length of that line is going to be 5 centimeters. And I'll draw it and we'll measure it just to make sure, and hopefully you can do the same. So if we have a measure of that line, oh look, you can see there, it goes to 5 centimeters. I was right. Okay, and I was right because I used Pythagoras' theorem. So what Pythagoras' theorem basically says is that if I take this side and square it, so 3 squared would be 9, and I take this side and square it, so 4 squared is 16, then I add my 2 squares together, so 3 squared plus 4 squared, which is 9 plus 16, and it might be helpful to copy all of this down. That makes 25. And, well, 25 is this side, which we said was 5 centimeters. 25 is the square of 5. So to put this theory in sort of more formal terms, if we take the two smaller sides, which we will call A and B, and it doesn't matter which way around I do that, and we have A squared plus B squared, that will always equal the longest side, which we'll call C squared. Okay, and that there is Pythagoras' theorem. I'm going to show you a little video in a second, which will demonstrate it a bit nicely. But I would like you to copy down this formula, and with a quick little label that these bits here, they're the smaller sides, and this C is always going to be the longest side, which actually has a special name. Hopefully you might recognize it. I've mentioned it before. It is called the hypotenuse. And the trick to knowing which one the hypotenuse is it's always the one opposite the right angle in a right angled triangle. And that's what we're going to be dealing with all this time. We're just going to be focusing on right angled triangles. Okay. I'm going to show you a nice little video, hopefully, of a demonstration of this. So if it doesn't work, you can go to YouTube and search into YouTube for Pythagoras water demo. And I think I'm going to show you the second result just because it's from a cool TV show, but the first result is fine as well. So hopefully you can see this. I'm not entirely sure because I can't actually see what you're seeing now. But this is going to be a little video from a TV show called QI from the BBC.
A squared equals B squared plus C squared.
Yeah, it's the
sum of the squared
sum of the two squares equals the sum on the hypotenuse.
Yeah,
Exactly.
that
You can
big
see
one
that.
should go into the other two.
So you can see here the yellow, that's the triangle. These are its two sides. And these are the squares of the two sides. They're literally geometrically expressed as squares rather than just mathematically as if that was, say, x. It's just not x squared, but it's literally the square there. And there's y squared. And it's supposedly equal to z squared, which is the longer side, the hypotenuse, because here's the right angle, here, these are not right angles, obviously, there's that. How can we show they're equal? Well, there are all kinds of ways, but here's one way. Yes.
Drum roll, please.
Oh, yes. All right, let's go.
Oh, that's very clever.
There it goes, pouring into the first square.
Yeah,
Is he going to fill it up?
Wow.
Oh, well, it definitely equals x squared.
Yes.
Does it equal y squared as well?
I need to go to the toilet.
There's y squared, it's filling up, it's filling up, it's filling up,
Wow.
it's full.
Alright, so there you go. That is a little demonstration. So what I'm going to add to my little formula here, which we drew, is just a little diagram of a triangle, if you bear with me. If that video didn't work, just I hope you've skipped ahead, otherwise you would have just been watching something going, oh, YouTube's still playing, look at that. Didn't want to watch anymore. Alright, so we're going to draw a little triangle. He used x squared and y squared, I think, when he's talking about it, but again, the letter is essentially arbitrary. It doesn't matter which one you use. I'm just drawing a little drawing of a triangle. I will use A, B, and C, and that's where we get what that video showed was they literally got a square. Okay, so when we say A squared, we're talking about the mathematical operation of squaring, but it was demonstrated there with the actual geometry of an actual square filled with water. And then you could see that when you added these two squares together, it will make up the same space as a square drawn off the side of C. And that is Pythagoras' theorem. That's what he discovered many years ago. If you want a little bit of homework, go research Pythagoras. Interesting man. There's a bit of a cult around him. There's almost like a semi-religious thing about numbers. Some people will also accuse him of murdering someone who he disagreed with on his maths. But obviously it's a long time ago, we don't really know. But if you want, go see if you can research Pythagoras and find out about the man as well as the maths. But we'll look at a few examples, okay? Then I'm going to say some questions. And hopefully the first example I'm going to do is you're not going to need a calculator, but for most of them you will, okay? So I have a little example, and again you can copy this down as I do. And we're just going to draw a little right angle triangle. I always like drawing the diagram just because it helps visualize what we're talking about. So we'll label this side 6 and we'll label this side 8, and what we're going to try and look for is this missing side x. Okay, and all we got to do is basically follow the formula and plug some numbers in. So I like to always write down the formula. Okay, so I'm going to keep writing it down on every single question. I'd advise you to do the same until you've memorized it off by heart, because this Pythagoras as a subject will come up pretty much every year as long as you're in school. So let's have a look at it. So the formula again was a squared plus b squared equals c squared. And now we're going to label the triangle. So we have this side I'm going to call A. I could have called the 6A. It doesn't matter which one you call A and B as long as it's the two shorter sides. So we'll call the 8A, the 6 we're going to call B. As you can see, my 6's and B's look pretty similar. And that means our last side, X, is going to be C. Okay. And then what I'm going to do is I'm going to substitute some numbers into the formula. So instead of writing A squared, well, I've labelled the 8 as A. So underneath I'm going to write 8 squared. And then underneath the B, I mean that looks like a 6 anyway, but we've labelled the side B as a 6, so we're going to call it 6 squared, and that equaled x squared, which is what we're trying to find. So what we've got here is essentially a little equation to solve. Alright, and we've done some equations with where the unknown is squared, where the x is squared, but we'll just work through this one together. So then we just need to do the next line of working out, where we can think, well, alright, this might be a bit confusing, I might not know what's going on, but I know what 8 squared is because it's probably at the top of my page somewhere. I think it is when we did the starter. 8 squared, 8 times 8 is 64. And we got 6 squared, 6 times 6, that is 36. And that equals x squared. Okay? And that means if we tidy this up again, well, I know how to add up. I've been able to do that for years. 64 plus 36, what does that add up to? It adds up to 100. So 100 equals x squared. Okay? Or just let's write that the other way around because I like to put the unknown first. X squared equals 100. So okay, something squared equals 100. Something times by itself equals 100. Well, if you know your times tables, that'll pop that straight away. X must be 10. You could again also argue it's negative 10, but given we're dealing in like geometry, you can't have a triangle which has a length of negative 10. And I know I didn't put any units here. That could be millimeters, centimeters, meters. It doesn't matter. But it can't be negative because it's a length. So x is 10, and that's our answer. So that's the complete example. You might even want to pause it here and copy it down if you haven't already. I think I'll do one more. I'll do one more which will require using this thing, and then I'll give you a few questions to do. So I'm just going to turn my page over. And we'll have a look at another one. So I'm just going to pick the numbers fairly arbitrarily here. And I'm not even going to use a ruler because it's just a diagram, it's not to scale, but we'll just label it with a right angle so we know it's a right angle, and we'll pick 7 and 9. There we go. We'll call this one Y for a change. So first step, same as always, I'm just going to write my formula out until I've memorized it. So that was a squared plus b squared equals c squared. We said the two shorter sides of the triangle were a and b, so that's going to be the 7 and the 9. So we'll call that one A, that one B. So that means this one is C. And we're going to substitute those numbers in. So I said A was the 9, so I've got 9 squared. And B was the 7. So I've got 7 squared. And that is going to equal C, which is Y squared. Okay, so now I've got another formula. 9 squared plus 7 squared equals Y squared. I'm not going to use my calculator yet, because I know what 9 times 9 is, it is 81, and I know what 7 times 7 is, it is 49, okay? So I get 81 plus 49 is y squared, okay? And then I've just got to add the 81 and 49 together, which, again, I'm not going to use my calculator, and I believe it comes to 130. 130 equals y squared. Or, if I write it the other way around, y squared equals 130. Now, if you're thinking of square numbers which times by themselves to make 130, you could be going for a while before you found one which made 130, because it's going to be a horrible irrational number, a decimal which goes on forever and ever and ever. But they could have asked this question on a non-calculator paper, so the simple answer is to say, well, how would you find y? You'd use the opposite of squaring to find y, which is the square root. Okay, so y equals the square root of 130. And if this was a non-calculator paper, you just leave your answer like that. You've got full marks. Great. As it happens, we've got a calculator. So all I'm going to do is type in the square root of 130. So that's the square root of 130 equals. And it's just told me, well, it's not told me anything. It's told me it's the square root of 130. Because that's what I say. That's like the simplest form you can put it in if you're not using a calculator. So as soon as we press SD to get as a decimal, we've got an answer. And technically that's not the correct answer, because that decimal will keep on going. This is only correct at however many 8 or 9 decimal places. It will keep on going. So I'm not going to write the full answer down. I'm just going to go say, well, that equals 11.401 ... I'm not going to write the full thing. And you know, if it's a calculator paper, it's probably going to tell you to round to something. Okay, so in this case I'm going to round to 1 decimal place. So I'm going to decide, well, is it going to be 11.4, 11.5? It's much nearer to 11.4. Alright, and then that's my answer. Okay, and I'm just going to quickly give you about 3 questions to have a go at, which you can pause and look at, and then I'll go through the answers, and then that might be enough. You probably want to try some additional work. So I've not used YouTube yet, but once I upload the video, I'm going to put a link to like a worksheet you can download and have more practice at in your own time. But I'll just give you some questions to do. I'm going to switch notepad. I've pre-prepared them. There you go. What I want you to do is find x for each of these triangles. I'm actually going to put some units on them. So we'll say this one's centimeters, obviously not drawn to scale. We'll say this one's meters, and we'll say this one is millimeters. Okay, and so your answer this time, I want you to have your answer is centimeters, meters, or millimeters, whatever number you get out. So what you need to do is you need to pause the video, have a go, and then once you think you've got an answer, unpause it. If you want to rewind and look back at the examples, please do. This should be written down in your book. So if you just basically follow all of my steps of working out and make your page for these questions look like how mine did for my working out, then you shouldn't have a problem. Okay. So if you pause that, and then when you unpause, we'll be ready to go through the answers. Okay, so quickly going through the answers. I believe that one I used as an example, but we'll do it again. So we got a squared plus b squared equals c squared, where it doesn't matter which way around. I'm going to call a 6, so we've got 6 squared, b will be 8 squared. Now it's going to equal x squared. So remember, these you could have drawn squares if you liked and actually measured the area. So 6 squared is 36, 8 squared is 64. That makes x squared, and if we actually add it up, that comes to 100. So x squared equals 100, or x equals 10. And I'm not going to forget my units because that could cost me a mark in an exam. 10 centimeters. Okay. And that was a nice one. I didn't need to use a calculator. They're actually called something fancy. We call the Pythagorean triple. So 6, 8, and 10 is what we'd call a Pythagorean triple, because Pythagoras' theorem works for that triangle, which is 6, 8, 10, without the use of a calculator. Okay, but they're very rare. You'll see them a lot in maths exercises because we'll deliberately throw them in there, so you can do it without a calculator. But in reality, they're few and far between those types of numbers. Right, B, I think I will need my calculator here at some point, but we'll do it again. So it's a squared plus b squared equals c squared. A and b are my smaller sides, so that's 4 squared plus 5 squared is going to equal x squared. 4 squared is 16, 5 squared is 25. And if we add that up, we should get 41. So x squared is 41, and now we will have to use the calculator to say that x is going to be whatever the square root of 41, okay? Because we need to undo this squaring to get x by itself and find out what x is. So I'm going to use my calculator here, and I've got 6.403 ... keep them going, and we'll round that to 6.4, 1 decimal place, meters. Alright, last one. I'm going to start it up here because otherwise I'll run out of space. I'm going to skip. I might have memorized the formula by now, or at least I've got it written down, so I'm not going to write it down again, but I'm going to 10 and 12, they're going to be my A and B. So 10 squared plus 12 squared equals x squared. And 10 squared is 100, 12 squared is 144. So x squared is going to be 244. So x will be whatever the square root of that is. We need to find that number. When we times it by itself, makes 244. and usually it's not a particularly nice number. So if we do it, again, it's not going to be a particularly nice number. It says 2 root 61, that's something called simplifying surds. I think we might have even done a little bit at the start of here, but I don't expect you to remember that. And that comes to, well, if we rounded to one decimal place, we'll call it 15.6. Interestingly, we've rounded down every time there. I'll write the full answer, 620 ... Okay? And so hopefully you've had a few questions to have a go at. Hopefully we got more right. I'm going to post a link underneath which will take you to like a worksheet so you can have some more practice. In reality, if this is supposed to be a lesson, it probably won't take you an hour because you don't have distractions of the classroom, of talking to the person next to you, me wandering off on a tangent talking about Pythagoras for 10 minutes. So you might be able to get things done more efficiently. I'm going to aim to try and do another video probably tomorrow to upload, which is going to be what happens if we have to find the shorter side. Okay, so far we've only looked at finding the long side of the triangle, but you could get asked to find the short side. Not going to be a lot different. If you can do this, you should be able to do that, no problem. Okay, but we'll spend the next week or two doing Pythagoras because we can do quite interesting things with it. Alright, well I hope you enjoyed it. Again, you can use Google Classroom, message me on that if you've got any questions, or you can use the comments on my YouTube video. I'll also have the office hours if you want to get on Zoom and conference with me. If you've got any further questions or you want to go over it or anything like that, I'll try and be available as much as I can. Alright, well thank you, hope you enjoyed it. Have a good first week back at school after spring break.